Hello, protocols, packets, and programs. We are now tuning in to a year already in progress. So far, someone has taken security seriously. A few thousand CVEs are in the wings. AI is the new ML, and supply chain has just entered the chat. Let's see what happens next. Which means, this week, we chat with Dan Moore from OAuth about the ins and outs of OAuth 2, when it's useful, and its secure use. In the news segment, Circle CI requires rotation. Auto industry websites could use some scheduled maintenance. Google speakers spark a 100K bounty, aftermarket code, and more. Stay tuned and stay tuned for Application Security Weekly.
This is Security Weekly, for security professionals, by security professionals. It's the show to learn the latest tools, techniques, and processes necessary to understand DevOps, application security, and cloud security. Your trusted source for the latest application security news. It's time for Application Security Weekly.
Your organization is building and updating business-critical web applications faster than ever. And with so much pressure to move fast, you may find yourself making trade-offs between innovation and security. Now you can build fast without sacrificing security with Invicti, the application security platform that helps your dev, sec, and ops teams work together to secure every website, web app, and API. With unparalleled accuracy, coverage, and automation, Invicti scales like no other AppSec solution. Discover why many of the world's largest organizations innovate securely with Invicti. Visit securityweekly.com/Invicti. Passbolt is a free and open source password manager that allows your team to store, organize, and share passwords securely. Passbolt is privacy first and highly versatile. It can be installed on-prem behind your firewall, used in a secure cloud, or deployed as a cloud-native application. You can check out the source code on GitHub, extend it with the REST API, integrate it with the CLI or SDKs, and even contribute. Get started with Passbolt for free now. Check it out at securityweekly.com/Passbolt.
This is episode 225, recorded January 9th, 2023. I'm your host, Mike Shima. I'm here with John Kinsella. Hello, John. And John is starting the year off on mute, but we also have Akira Brand. Hello, Akira.
Hi, Mike. How's it going?
It's going quite well. Just so you know, John, we want to thank you and all of our listeners for listening to and watching our podcast. We want to ensure that we are creating the most relevant and useful content for you. Please take a few minutes to complete our listener survey so that we can craft our content based on your needs. Visit securityweekly.com/survey to submit your feedback. Dan Moore is head of developer relations for OAuth and currently helps educate developers about authentication and OAuth. He's written, contributed to, or edited a number of books. A former CTO, technical trainer, engineering manager, and longtime developer, Dan has been writing software for over 20 years. Hello, Dan. Thank you for joining us.
Hey, Mike, Akira, John. Thanks so much for having me.
Love to have you here. Help us, starting off the year on some fundamentals, some basics about authentication. And maybe before we get into OAuth, maybe give us a quick evolution perhaps of securing APIs. Why are what brought us to OAuth in the sense that it's useful, something we should be thinking about?
Sure. So I would say that in the early years of the 2000s, people were starting to build out what were called APIs. And API obviously is something that's been used by software developers for a long time. So when I talk about APIs in this context of this episode, we're talking about basically calls over the internet, typically using HTTP or HTTPS, typically with some kind of textual representation. So not necessarily talking about like gRPC or maybe SOAP, but not like Corba or anything like that, right? So just want to kind of set the good context. But as people started to realize that you could use the internet as this kind of layer in your applications and offer up functionality over the internet, some of the traditional ways of securing kind of inter-application processes or inter-application communication kind of became less useful, right? So it used to be you could use an IP allow list, or you could require someone to be on a VPN before they got access to an application. With the rise of the cloud and the rise of SaaS and the rise of everybody wanting to use their own devices, that model became less effective. And so people started to build these applications that leverage a lot of APIs. And, especially in the 2000s, it was a lot of kind of mashups and using external APIs. But I think now there's a lot of people realizing that they can have their own internal APIs and have applications that use those. And so it's a way of kind of separating teams and allowing different developers to focus on what they do well, and having this really nice, clear delineation between kind of the front end, especially if you have multiple front ends, right? A spa, a mobile app, etc. And then a back end, which just generates this JSON. That's the kind of the textual representation is very common right now. People aren't using XML as much, although there are some other options too. And so, the first way that I've seen a lot of people use to protect these APIs. Well, first of all, actually, let's take a step back and say, why would you want to, right? Like, why can't you just rely on the secrecy of the front end application or something like that? And there have been a number of pretty high profile situations where an API was exposed or unauthenticated or not throttled, and people, bad people, went and grabbed data. The examples I have are mostly from 2021. I haven't looked last year, but Parler, that right-wing website in the US, people were able to download the entire block of data from them. Clubhouse actually had public data that got exposed. And I think that there's kind of a difference in kind between someone looking up one person's profile on Clubhouse versus somebody downloading everybody's profile on Clubhouse. So that's a case where authentication and throttling are kind of tied together. And the same thing happened in LinkedIn. And this I can drop the link actually, and we can put it in the show notes. But those are three kind of really high profile cases where people didn't protect their APIs, and so they ran into issues. And again, public JSON APIs over HTTP, not talking about other kinds of APIs. Sorry, I feel like I'm talking a lot. So does that help set the context?
Yeah, this is great. And you hit near the end there, one of the important aspects too of OAuth can start off a bit ambiguous. Are we talking about OAuthentication or OAuthhorization? And especially, from your LinkedIn example, or, who is the identity of visiting this site, and what data should they be accessing? Meaning, I have an OAuth token. I should be able to ostensibly just see my data, not Dan's data or Kira's or John's. So maybe, there's a lot of paths to go down, but tell us a bit more about the authentication aspect of OAuth, and what role that has in here.
Sure. So I think one of the big things that OAuth has done, and they were building on the standards bodies were building on previous examples. So it's not like OAuth came up with this idea out of nowhere, but there's this concept of an authorization server, which is really where the user or the entity is authenticated. And that authorization server generates a token, which is passed back to the client, which is kind of the piece of software that's driving the initial request. And then that client can present it to other API servers, other resource servers, other pieces of software that can look at that token. But the nice thing about having everything isolated, the authentication event isolated in the authorization server, is that authorization server can do whatever it wants to know who I am, right? And it can transparently upgrade that process. And as long as it's still generating the same kind of token, every application downstream of that consumes that token gets the benefit of higher assurances, new technologies, other benefits that happen over time without changing the application at all. So an example of that I'm sure you all are very familiar with is lots of previously username and password was kind of enough for me to be authenticate. But now more and more people want multi-factor authentication, whether that's an SMS, an email, a YubiKey, something else. And if you have an authorization server set up, you can transparently layer on that second level of authentication, and you can be intelligent about it, right? There may be some applications that you don't care for that second level, or there may be some that you want 3 or 4 different levels of assurance. And you can do that all through the authorization server. And as long as it still generates that token in the same format, all the applications downstream can benefit without having to change their code at all.
Yeah, and so we're definitely going to get into some fun here with the different types of tokens that are involved within OAuth, and a bit of the dance that you're describing here. You describe the client. This is your web browser, your mobile device, for example, and that authorization server, and then the resource server are another term of art here. What are you interacting with? Maybe help us a little bit about those three major components, the client, authorization server, and resource server, because one of the neat things about OAuth that I think you were getting to is that you might only own two of those three items, and this is how a system, an application might say, we don't want to handle raw passwords. We want to delegate that perhaps out to someone else and have them enforce the FIDO keys or the strong authentication, which sounds to me like a good decision, but there's a lot of traps to make sure that we follow through on that decision in a secure way.
So I guess I want to make sure I give you what you're asking for. Are you basically you want me to kind of walk through what each of those roles are, the major players, or?
Yeah, let's start with just that client authorization resource and then pick them apart as they are within the same org or different orgs.
Sure. Yeah. That's a great thing. And we actually have, at FusionAuth, we've categorized these things as OAuth modes, which is totally a non-standard way to think about it. Again, I can share that link. But the idea is like kind of who owns which piece really matters on certain kinds of functionality, right? But anyway, so we have a client, which, as you said, is a browser or a native app or something that is wanting access to data. We have an authorization server, which is the thing that authenticates the user and, as the name implies, finds the correct authorization level for that user and generates what's called a token. And then we have the resource server, which is the thing that protects the data or the functionality. So the canonical example is like a to-do list, right? So a resource server might let you create, add, update, change, share to-dos. And every time you're interacting with that API that's exposed by that resource server, it should be checking the token to make sure that it's not expired, to make sure that the token was created for it, to make sure that the token was signed correctly or otherwise created correctly by the authorization server. So those are kind of the three main components. I think a lot of people get caught up in OAuth and they think like signing with Google, right? Which is the case where I'm a client and Google owns the authorization server, and then Google conceivably could own the resource server too, right? Like if I want to write something against a Google Calendar, I'm going to authenticate against Google. Google's going to give me a token, and then my client can present that token to Google Calendar to get my events or to update my events. And that's definitely one of the modes that is common, but a lot of times what we see today is people own all three, right? And so they own the client, they own the IDP, and the reason why they might do that is sorry, I just used another term of art, sorry. They own the authorization server, not the IDP stands for identity provider, which is used by some other standards to basically indicate the same thing, the thing that authenticates the user. So if you own all three, then there are things that just don't make sense. Like a key part of OAuth is scopes. And the idea of scope is, again, let's go back to the Google Calendar example, right? Where I'm a client, I'm writing a reminder app. And so I want to get read-only access to the calendar. But I will tell Google in my initial request, I'll say, hey, I want read-only access to a calendar. The user, when they're sent over to Google to authenticate, will get a screen that pops up that says, this app is looking for these permissions. And if I'm a user and all I want is like reminders, and it suddenly says, I want, my application wants to be able to create calendar events, my antenna should tingle and I should say, no, I'm not going to give that permission. Now, how many people actually read those pop-up screens is a different question, but that's the idea of scopes. And that makes total sense with Google when basically my application is getting delegated access to data and functionality that it would normally have. But in the case where I own all three pieces, my to-do app, I just want that kind of architectural separation. and maybe there's some additional functionality the authorization server offers, or I hang multiple apps off the authorization server. But it doesn't make sense to ask for scopes because I have, as the client, like if it's a native app and I have the authorization server and the IDP and they all live in the same space, as the company providing the to-do app, I have access to your data anyway. So what does it mean for me to ask for permission from you, the user, when I already have access to the data?
Yeah, and I think you're hitting an important aspect there in the sense of authentication. In other words, who is visiting this app, who's using it, and the granular authorization. That authorization is more of granting to that third-party access, like you're describing, that scope, to use those terms. And I want to come back to that scope in a second to talk about, because that has definitely some bearing as you're building up an API. How do you define and handle scopes? But there's also the tokens that are really interesting. And the tokens are, let's say, standardized, but easily misused, especially if we throw Jots, JWTs, into the mix here. That is the here be dragons of access tokens. So I think many of our listeners might already have some whatever the opposite of warm fuzzies are when they hear the word Jots. But tell us, for others, tell us a little bit about Jots and maybe access tokens in general, and what are the security considerations about, one, the different types of tokens that we can get in the first place from an OAuth dance.
Sure, yeah. So let's talk about the three kinds of tokens that you typically see. So, and each of them is basically used by a different part, right? A different party of the system. So we talked about clients and authorization servers and resource servers. And again, clients are the things that are asking for access to data. Resource servers are the things that control the data. And the authorization server is the thing that the user authenticates against to get correct levels of authorization. So the first, which you alluded to, is the access token. And this is a core part of OAuth. And the important thing to realize is that access token is, according to the RFC, supposed to be kind of it's a string that you can't really look into. It doesn't have any structure. You're not guaranteed to look at it. Basically, it is supposed to be created by the authorization server, handed to the client. The client's never supposed to examine it, and then it gets passed to the resource server, and then the resource server needs to handle it itself. And usually, if you're going again with like kind of vanilla 6749, which is again like a 10-year-old specification, and there's been augmentation to it, it's supposed to somehow talk to the authorization server and say, "Hey, is this token valid or not?" There are other ways to do this, which you alluded to, but. So the access token is designed for consumption or to be used by the resource server. Another token is the refresh token. And one of the benefits of using something like OAuth is they've thought through a lot of use cases. And one use case they've thought through is, hey, I have this access token. Eventually it's going to expire or be invalid. How can we get a new one without necessarily asking the user to re-authenticate? And so this is what's called a grant, which is basically just kind of a workflow. And there's a number of defined workflows that are in the specifications and the original one and the follow-on ones. But the refresh token is designed, again, it's not supposed to have any internal structure. You pass it to the authorization server, and the authorization server can say, oh, this looks good, and I'm going to grant a new access token based on that. The third kind of token, which is designed for consumption by the client, is called the ID token, which is a layer on top of it's part of a layer on top of OAuth that is very commonly paired with it, called OIDC, which stands for OpenID Connect. And the ID token is explicitly not supposed to contain any sensitive information. It can't be presented to anybody, but it includes information about the user and the authentication event. So what people quickly realized is that actually there was value in creating a token that actually had some internal structure, so that the resource server didn't necessarily have to always go back to the authorization server to get information about the user that was represented by that token. And there are a couple of standards out there for this. The one that's by far the most common is called a Jot, which stands for JSON Web Token. And there's a number of things you want to be aware of if you're using Jots. The first is that you are allowed to So the first is that Jots, I just want to be careful here. You can encrypt a Jot where the payload is hidden, or you can sign a Jot where the payload is not hidden, but the validity of the payload can be determined without ever talking to the authorization server or any other thing. And again, signed Jots are more common than encrypted Jots, although I did see an encrypted Jot just the other day. And if you do use a signed Jot, you want to make sure that you verify the signature before you do anything else. And the reason for that is that if the signature doesn't match, then you can't trust the contents of it. And this gets to one of the things that I think is really important when you're consuming a Jot is you absolutely want to use a library that's preferably an open source library, something that someone else has written that's been battle tested, because there's this weird dance where you need to look at the Jot to determine the key that was used to sign it, because they're often signed with public-private keys, right? So you need to look at it inside it to see what was used to sign it, but then you use that same value to like verify it, and then you can process it further on. And so it's a little scary to look at something to determine what you can use to verify it, because you haven't verified it when you first look at it. By definition, you can't, right? So there's just some subtleties around that, and which is why I always encourage everybody to not write their own thing. And I have not encountered a library yet, or sorry, a programming language yet that didn't have a good JWT validation library.
Yeah, and definitely highlighting that distinction between, especially with Jots, are they confidential, encrypted, or the integrity? Can they be mucked about with, to use my favorite term of art there? I want to hit a little bit about the Jots and the tokens as well, because they're cookie-like, but they're not cookies, because they're not only just showing up in a very specific HTTP header. They could actually show up within a URL, within a redirect parameter. And that has some security implications to it. So what are some good ways to either handle and present these tokens in different use cases, and what should developers be looking out for, making sure that where these tokens shouldn't show up because they could be misused in some way?
Yeah, great question. So the first thing I would think of is you want to be cognizant about that access token lifetime. And so you can set lifetimes from 1 second to 10 years of an access token. And if an access token is a Jot, that means that the resource server will kind of accept it for that lifetime. Or actually, I guess that's true of all access tokens. But the difference is with the Jot, because it has that distributed nature where it's signed by the authorization server with a private key, and then you can verify with a public key, you don't necessarily talk to the authorization server, say, is this token valid? Is this token valid? So thinking about lifetime and making it as small as you possibly can, especially if you're using the refresh grant, is a good first step, right? And we actually have some of our clients use kind of 1 second access tokens, right? So it's issued and then it's used, it's kind of a one-time use, and then it's gone. So if someone steals it or it gets put in a log file or whatnot, it's not a big deal. The second thing is, yes, to think about where they go. And at FusionAuth, we tend to recommend putting them as HTTP only cookies. And that has some kind of functionality limitations, but we think that like secure cookies, especially if you use same site of lax or strict, is a pretty good option. Again, as long as you can accept some of the functionality limitations. If you put them in local storage, that's going to be kind of scary, because that means that any JavaScript that's executing on your page can rummage around. Same thing if you store it on a mobile device and don't put it into the key store or something else that's protected and isolated that application. The other thing, as you mentioned, is you don't want to put it any place that it might get cached or get accidentally written to a log file, because you can think about these as, they're not as powerful as the username and password, but if you, with some exceptions, if someone steals a token, they can present themselves as you to the resource servers. And that's what we're really trying to avoid from a security perspective. the exceptions are there's some new standards coming out or have come out that actually bind a token to a client. And there's one called MTLS, which uses PKI. Actually, they both use PKI. And then there's another one called Depop. And I know there's some implementations out there. I haven't actually done an implementation with either one of these, but if you're looking for higher assurances, what that does is that actually kind of means the client has to hold a private key. And I'm hand waving here a little bit. It signs the request in such a way that the token is inherently associated with that client, and nobody else who doesn't have that private key can create the token in such a way that the resource server will accept it.
Yeah, and that having that stricter tie to the client helps with the replay attacks. Helps if that those tokens are leaked into, like you said, into a debug log, or they're hit by a CSRF perhaps, or something like that, or maybe not CSRF, but the other types of attacks. But one of the things I want to highlight too is we have been talking actually specifically about OAuth 2.0. Maybe we didn't say that at the beginning, but it's been around for 10 years. So I think there's no reason anyone should be on 1.0. Fingers crossed. I realize that
Twitter.
may not be a true statement. Yes, there
Twitter.
we go. But let's put our future hats on, because you mentioned like Depop, for example. In version 2.0 is out here. If there was a 2.1, let's say, before we're even getting to a big version 3, what would be some ways of just using version 2.0 in a most secure manner? Because as we've seen a lot within a lot of standards, within a lot of situations, there is, here's what it looks like, but here's the hardening version and all the effort you have to put in. So what's some of the hardening work that someone could be thinking about for 2.0?
Yeah, and there actually is a 2.1 that is kind of working its way through the standards body right now. I haven't seen a ton of action on it lately, but I know that I wrote an article a couple of years ago that was kind of talking about the pieces that are different. And so one of the things they do is they deprecate what's called the implicit grant, which is a way for you to get a token in a JavaScript world or JavaScript application where the token gets delivered as part of the URL. And so obviously that has some negative security implications because, again, if it's in the URL, anyone can get to it. Another is having refresh tokens be one-time use or binding them to the client somehow. And either one of those helps increase the security of it, because you can imagine that since refresh token can be used to create a new access token, it's a pretty powerful piece of information, a pretty powerful piece of data. So one-time use, obviously, you can keep an eye on whether or not a refresh token's been used repeatedly and log the user out or invalidate all the access tokens that were tied to that refresh token. Those are some of the ways that OAuth 2.1 tries to make things a little more secure by default.
Yeah, part of that too, I want to touch on some of the responsibilities or maybe the expectations of developers, because one of the things I love about OAuth is that you can actually rely on that third party to do the tougher part of strong authentication and just assert or attest that, yes, this user authenticated as Mike. Here's the token that I'm going to give you, and I trust that token for whether I should or not. But to go back to our discussion of scopes, and this maybe is a bit obvious as I ask the question, especially for security folks, but maybe not for developers. When I say like we wanted our read-only calendar or read and write to the calendar, OAuth doesn't magically create that enforcement of that. This is business logic that the application actually has to implement itself, right? If I'm an AppSec person, I say, go implement OAuth. We want to have granular permissions with it, and we want to use our Jots with scopes. There's a lot of work that I just set aside for our dev team.
Yeah, I mean, I think it actually goes deeper than that too, right? I mean, you have the scope level where, and let's just be honest, when you have scopes, you're actually putting work onto the end user as well, because they need to know enough to know, hey, this application doesn't need this permission. Why are they asking for it? or this application does. And, I don't know about you all, but like, I like to take as much work off, especially security oriented work, away from end users as possible, because it's a lot to ask. But the developer, that resource server, we kind of talked about verifying the signature, right? And some of the complexities around that. But you can't just stop there. You need to verify the issuer, you need to verify the expiration time, and you need to verify the audience that the token was created for. And the idea of the audience is, you could have an application that you could have multiple different APIs with an organization, right? Imagine a to-do API and like an accounting API. And you don't want a token that was created for the to-do API where maybe Dan has admin access to be presented to the accounting application, and the accounting application say, "Oh, there's an admin here. I'm gonna let him transfer money," right? So there is. I mean, the nice thing is that a lot of this can be standardized into a business logic specific library that you could share across different applications. But it absolutely is organization business logic specific, organization and application specific business logic.
So you're walking a little bit into something. I've been sitting here sort of like letting you build this out for this question. And you made a comment a few minutes ago, which really resonated with me. The idea of if an organization owns those three pieces, the auth, auth Z, auth N, as well as the app, right? That then in that situation, I've got this funny feeling, and I think I've probably seen it in previous lives, that someone's like, "Oh, we know what we're doing. We own all three parts. We don't have to worry as much about the scope or the specific privileges and all these type of things." Is that does that resonate with you? Is that something you've seen out there, where in the situations where someone has everything that they're like, "Oh, we'll just use, the defaults"?
I mean, I understand where you're coming from, and that's the same reason why some organizations have everybody be admin on the Google Apps, right? It's like it makes things simpler, but there's a reason why people start to introduce controls and introduce separation of concerns and principal least privilege. So if someone were to come up and say, "Hey, we own all three pieces, there's no need for separation," I'd say, well, there actually is. And it's because people make mistakes, and occasionally it's coming from inside the house, right? There are bad actors inside the house too. So I think it's a really good point, though.
But
John.
So I'm teeing up, honestly, sorry, I'm not trying to do a gotcha, but I'm teeing up for the second part of that question, which is part of the reason that I think that people go down that path of saying, "Oh, we're just going to use it," is because, we're 20 minutes in here, probably more or less 15, 20 minutes, in the complexity of just just of OAuth. That's a lot for a dev team to wrap their head around. Like once you've got it done right, hopefully you're good and you put the effort in, you're going to reap the rewards. But I think for a lot of folks that start building something out there, it's like you look at this, correct collection of craziness. It could be probably a 30-minute discussion for someone, just like, do we use a URL or a cookie or web storage, not alone all these other parts. So it's like, I guess where I'm coming from is like it's if you were advising someone to start right now, is there like an easy sort of defaults, all good, it's just going to work and we don't have to worry as much about it? Or does everyone have to put this effort in?
So there's 2 points here, right? One is that you're using OAuth, and I absolutely agree there's some complexity. That's one of the things why I continue to not worry about having a job, is I explain this over and over again, right? And it was scary to me before I got into this field, right? This particular domain. So I understand and I have sympathy for that. The benefits are that you get to stand on the shoulder of giants and people who've thought through all kinds of different security use cases and different kind of niche use cases, and you get all that as long as you're, following and understanding the protocol. The other piece I'd say is a lot of people start with API keys first, and they don't bother with OAuth, and I think that is head and shoulders above not protecting things at all. And I think that you start with API keys, which is basically a simple high entropy string that's assigned to a user. Then maybe you centralize them because you have API keys across multiple different APIs. And then you tie them to a user based on authentication event. And then you realize, oh, I want to put some structure into this API key. I don't want it to be high entropy string. And then you say, oh, we should really rotate these automatically. And then you say, I think I want to make sure that I can refresh them without, create new API keys without the user authenticating again. And now, congratulations, you've reinvented OAuth. So I'm not saying you shouldn't start with the simplest thing that protects your APIs. I think that's true. I think that there's a lot more accessible OAuth documentation and servers. There's a number of, FusionAuth is free if you run it yourself. There are plenty of other open source ones out there. There are lots of libraries. So I don't have a straight answer for you, John, because it also really depends on the team and the team size. And, there's always this tendency to future-proof as a software dev. And there's the Yagni principle, but there's also the standing on the shoulders of giants principle. And I can't answer that question in the general case.
Yeah, one of the things that also hit me, and another full 30-minute conversation be easy to have, is do we want to have this stateful or stateless? And I think that touches a bit on the Jots. And can you revoke them? How long should they live? How do you rotate them, for example? And there's obviously benefits on both ends in terms of complexity to design. So maybe one of the end wrapping up questions here, as we're getting to the end, is sort of saying what are some of the maybe worst case scenarios just to be on the lookout for, or sort of along John's questions too, as what if you're doing this by default, or using a particular library or particular design pattern, what are just some good things? Maybe let's find what are some of those giants versus some of those dragons that we should be avoiding.
Sure. So the first thing I'd say is use the authorization code grant with Pixie. That's kind of, as long as sorry, I should take a step back. There are two main use cases we see a lot, where there's one where a user's involved, and there's another where it's like a cron job or a script. So if it's a cron job or a script, use the client credentials grant. That's kind of well understood. That's the easiest OAuth grant to get started with, because it's basically a username and password with, a token that gets basically handed out. The username and password just get associated with a service account or something like that. And if there's a user involved, then you want to use the authorization code grant with Pixie. That is good across all different kinds of clients. Pixie is this way to basically prevent replay attacks, is kind of the simplest way to think about it. And, store your Jots carefully. Again, we have our recommendation about cookies. I think you can also, I've seen them stored in web workers or in memory, which again, they all have their trade-offs, right? If you store it in memory, when someone reloads the application, then they have to re-authenticate. But at the same time, I'm not aware of very many attacks where someone's kind of rummaging around in the browser memory to look for certain strings. And then the last would be as the resource. This is something that you pointed out, Mike. Like, as the resource server, you're not kind of scot-free by just saying, "Hey, I use OAuth and this token is not expired," and the signature checks. Right? There's other things you need to do deeper into your analysis of this token that are important. Whether that's checking scopes or other kind of. Well, actually, that's something we didn't even talk about. One of the benefits of tokens is that you can actually put whatever you want in there. And we talked about encrypted versus signed. You could put attributes of the user that aren't public, or that don't need to be private, like this user's a premium user or something like that. And again, that's all business logic that you need to check on your end. So does that address your question? I'm not sure.
Oh, yeah. And it definitely opens up to a much longer conversation we should have. But speaking of scopes, we want to make sure we expand the scope so Akira can get in one last question as well.
For sure. So if you don't know Dan from FusionAuth, you may know him from his advocacy for early career developers with his book and publications Letter to a New Developer. So Dan, I have a question for you in that realm. To a junior developer, this might seem extraordinarily overwhelming. So what advice would you give a beginner to start getting their hands dirty with OAuth?
Yeah. So I think that a really good place to start is, well, first of all, I'd take a step back and say, as a junior dev, if you see an API that's not protected, you should ask why. And you don't have to jump into OAuth, right? You don't have to like beat the senior developer around the head, but just say, hey, I'm curious, why aren't we protecting this API? And maybe there are ways that the API is protected that aren't obvious to you. Because that's really kind of foundational. More important than OAuth is just making sure your APIs are protected. The second thing is, I would say I'd look at it. It's tough because authentication and OAuth in general are something that you need to do well once per application, then you forget about it, right? And we've all been there with other aspects of applications. So I'd say you want to think as a junior dev whether it's something that you want to dig into or something that you want to kind of figure out kind of what the high level solution is and not really understand it. And I think both those are paths that are totally awesome, right? Not everyone needs to be an expert across the entire stack. You just need to make that decision. And if you do decide you want to dig into it, we have a modern guide to OAuth that I think is fairly accessible. I know there's some other docs out there, and I think downloading it and playing with it in a non-scary production scenario is a really good way to get started.
No, that's a wonderful answer, and I love that initial point. Why isn't this API protected? Because that is a wonderful open-ended question that can generate a lot more conversation, which we are out of time for a lot more conversation, Dan. But I have to say thank you for helping us navigate the IDPs, the OIDCs. We didn't mention SAML, but we could throw that in there, the JWTs, the PSATOs, and we managed to avoid the WTF acronym as you were describing all this. So thank you very much, Dan.
Thank you so much for having me.
I want to thank Akira and John as well, and all of our listeners. We're going to take a quick break and return with news of the week.